All right, it's officially 1 o'clock, so we'll go ahead and get started. Thanks for being here, appreciate it. We're doing section 6 and 7 this week, so before we get started in any of the new stuff, does anybody have any questions with any of the old stuff? So anything up through section 6, so, well, through 5, I guess. And it can be anything, everything. I have updated grades since we had stuff due last night. So you do want to check in Ivy Learn and make sure that your grades from web work were transferred over correctly. I mean, I try. I don't make mistakes on purpose. But there are times where you might have gotten a 77 and I type in 7, missed something. So you do want to make sure that your grades look right. Double check. I am never offended if you question something of, can you please check this grade? I think it's wrong. Never offended. So double check those. Let me know if you see any errors or anything I need to check. And that's great. So while I'm babbling, I see there are no questions in the chat box. So I will assume everything is going well. Our grades are pretty good in this class right now. It's early, but doing pretty good as we're halfway through Unit 1. So let's go ahead and get started here. 6 and 7. So what's due this week? WebWork 6 and 7. So 2 sections. We do have our first Excel assignment this week, and it's inserting pie charts. In the announcement, as you may or may not have noticed, if you've come to every session, you don't need to watch the recorded session, but I always put the video of the recorded session in the announcements. And this week, they will have this session, the live session recording, and then underneath that will be a second video, and that will be the Excel help video, because those are not on that spreadsheet that I sent you at the beginning of the semester. So when you go to do that Excel assignment, which is found in Ivy Learn, if you have questions like, I don't know how to do this, if you're not proficient with Excel, that's okay. Watch this video. It's not very long. I think it may be 4 or 5 minutes max, I think. And it will walk you through step by step of how to insert pie charts. And if that's not clear enough, email me. I can create a second video with another example and try to maybe break it down more. So that video will be in the announcements with the live session. And then you have a quiz and discussion board. Make sure, I think all of you guys did the discussion board this last week, but I had a few that just, I guess, forgot the discussion board. So remember, after this live session, get in there, answer those questions. If you have questions about it, let me know. But, those discussion boards, those are easy points. So you don't want to throw those away. So make sure you're getting those discussion boards done. All right, so let's go ahead and get into section 6, which section 6 is the application of per capita and proportions. So, section 4 was per capita, section 5 was proportions, and now section 6 is getting into some applications. So just what do these things mean? Well, just a kind of overarching, when we talk about the GDP, that's the gross domestic product. Okay, so gross domestic product, and you might see these words, and that's why I just kind of want to talk about what they are. The gross domestic product is basically goods and services produced by a country, and you will see quite a few examples in the packet, and maybe even in web work, homework, where they talk about the gross domestic product. And we might even talk about the GDP per capita. Now let's just refresh. Going back to section 4, what does per capita mean? Per capita, what does it mean? Good, Matt. Per capita means per person. So if you recall from this, we talked about the word per simply means divide. So you would have the GDP divided by the people. And there you have your ratio. So the gross domestic product is just a new concept, but it's a dollar amount, and there's nothing really new that goes with that. So we'll get more into that in a minute. But then we have CPI. The CPI is the Consumer Price Index. And this Consumer Price Index, which we will have a few examples in here about it, the Consumer Price Index basically deals with inflation. And it will let you know the percentage basically of how much goods and services have gone up. So, if gas was $2.40 last week and $2.60 this week, well, there's an increase, and the Consumer Price Index would give us a factor in which to use if we want to find other values. It'll make more sense when we get there. But the Consumer Price Index, that is located on page 44 in your packet. And I know that we don't do problems out of our packet in this class, but, well, in the live session here, but you will need page 44 because it has the chart. So I do ask that if you don't have your packet out, you kind of rustle around and get it out, and just have page 44 open here in a bit, because that's what we're going to need to get through. So we're going to need that. All right, let's go ahead and get to some problems, because talking is boring. So first question has two parts. In 2005, the federal debt in millions, that's kind of important, was 1,436,200 million, and the population of a particular country was 120 million. A, compute the federal debt per capita. Now, as Matt told us earlier, per capita means per person. So we want, in this case, federal debt, per implies division, and then we want the people on the bottom. Okay, so this is kind of a refresher from section 4. The nice thing about this, which is it's nice for this particular part, it's not always nice. Oh, wow. We have a federal debt of 1,436,200 million, right? Hashtag details matter. It says in millions, we got to have that, over the population, which is 120 million. What's nice about this problem, besides the fact that it's a pretty color of green? Excellent, Lillian, excellent. Can I just call you Lil? Is that okay? It rolls off my tongue a little easier. They're both in millions. That's what Matt wrote. Excellent, thank you. Okay, so the nice thing is, yeah, they're both in millions, and that lets us reduce right off the bat. We don't have to worry about those units, so we can just divide our numbers. If we divide those numbers, what do we get? And we can round to the nearest dollar, round to whatever you want to. It's your world, I'm just living in it. But what do we get when we divide that? All right, thanks, Logan. And this is a dollar amount, so we are at $11,968.33. And I'm going to give you a high five because you went to the nearest penny, which I do appreciate. So this is a made-up problem, but you know, what this means is that in this made-up country, their federal debt, if everybody would pay $11,968.33, it would wipe out their federal debt. Well, I don't know about you, but I don't have $12,000 sitting around, right? So, but that's the meaning behind this value. This is the federal debt per capita. So per person, that's the federal debt. A little bit of a refresher from section 4, but now we're going to build on that. So keep this federal debt dollar amount in your mind. Erase the drawings, move on to the next one. There we go. All right, and this, I know that your section 4 homework was already due, so this might be a little late in having this example, but if you, I sent out an announcement with a video about changing big numbers last night. It might have been helpful to some, it might not. That's completely, you know, who knows. But the federal debt increased by $1.4 trillion between 05 and 15. So what was the new debt? Well, remember the old debt was 1,436,200 million, and the increase plus 1.4 trillion. This is similar, but it's not exact of the problem in section 4 that you had to do. The deal is you have to change within big numbers. And I kind of just want to talk through this a little bit because it's good to have an idea. Even though that homework problem is passed, it's still good to have an idea of how this works. So remember that million means 6. So this right here means times 10 to the 6th. And we know that trillion is 10 to the 12th. So if you're thinking about how do I make these both in trillions? Well, if I go 3 places, 1, 2, 3, that would put me in billions, right? Because 6 plus 3 is 9. So I would have 1,436 billion, because that is 10 to the 9th. Well, I don't want billion, I want trillion. So if I would go 3 more places, this goes back to section 3 when we talked about, every 3 places you change names. If I go 3 more places, well, that would change this to 10 to the 12th, and that gives me trillion. So I end up with 1.436 trillion. If this doesn't make sense, stop me. So then if I take my new, it increased, I can add 1.4 trillion. Now that they're both in the same units, I can simply add. 1.436 plus 1.4 gives me 2.836 trillion. So it's a matter of moving decimals to jump between names, from million to billion to trillion, by using, 3 decimal places at a time. Does that make sense logically? And did you see how I did that? Did all of that make sense to you guys? Got a yeah, yes, good. Okay, excellent. These, scientific notation, all of that, once you get going with it, it's not too hard. But sometimes when you move between numbers, it's just good to kind of see it a couple times. So, okay. Let's move on to the Consumer Price Index on page 44. I've already talked about this a little bit. And if you don't know anything about inflation or CPI, it might be something that you want to go back and maybe read through in your packet. There is the video that goes with the CPI pages. The first part of that is all kind of getting yourself familiar with the table and how you use those numbers and what those numbers mean. So if the CPI or inflation is kind of a new concept to you, that page might be very, very helpful. If you're just interested in the math, well, that, my friends, I can help you with. So we're going to do this first problem together, and then I'm going to cut you loose on one. This is where you're going to need page 44. So here's the deal with CPI. You know that you need to use the CPI in that chart in your packet if 2 things happen. Let me back up. If 2 things happen, the first thing that needs to happen is that you're comparing years. So if you read a problem and you notice that they're comparing 2 different years, 1990 to 1980, whatever. If you're comparing years and we're talking about money, if those 2 things are true, then you know that you have to use your CPI table. Always comparing years with money. Okay, so now we can do a problem together. So I purchased a bike for $900 in 2014. What would have been a comparable cost in 1980? Right? So you kind of want to see, do I have those requirements? Well, I'm comparing 2 years. So I'm talking about 1980 compared to 2014. And we're talking about money, right? $900. So I always set up my CPI problems the same. I always put dollars on the top and I put CPI on the bottom. So I'm going to just put my proportion in this box. I like to have these labels. So you can see the left ratio is 1980, the right ratio is 2014. Money goes on the top, CPI goes on the bottom. You'll notice that in this particular problem, the only value they give us is $900 in 2014. Well, 2014 dollars goes on the top, so 900 goes here. You're trying to find a comparable cost for 1980. That's my unknown value for X. The bottom 2 values come from that table. So if you look at that table on page 44, you'll notice that 1980 has a CPI value of 82.4. And 2014 has a CPI value of 236.736. I lost my decimal point. Okay, so do you guys see where those numbers came from in your packet? Okay, solve that proportion while I answer my phone. Hi, Rachel. All right, sorry about that. We're having some spring scheduling difficulties. Did you guys solve this for me? What did you get for an answer? $313.26. So a whole lot cheaper buying it in 1980. Of course, that was before I was alive, so that would be difficult if this was me, right? Do you see how we set that up, where the numbers came from, how it all works? I feel pretty confident that we can solve proportions because we did that very well in section 5, but now we've got to do the application and change things a little bit. Okay, any questions on how that problem was set up or how to solve it? No? Okay, then I want you guys to try this one. Oh, crap. Okay, try this one on your own. All right, talking about the setup for this one. We know we're comparing 1978 and 2007. It doesn't matter which year you have in which spot. They're interchangeable. Again, if I'm going to put my dollars on the top and CPI on the bottom. So here's my proportion. Where does 49,000 go? On the top of 1978, right? So top of 1978, we're trying to find a comparable price for 2007. Thanks, Matt, for answering that. And then your CPI. Hopefully you got your CPIs. Let's double check those. 65.2 and 207.342. Pretend that's a 3. And what'd you get for an answer? Excellent, Logan. 155, 824, and 51 cents. And this is money, so unless otherwise specified, you should always go to the nearest penny because that's how we deal with money. Questions on CPI, setting it up or solving it? Everybody do okay? All 4 of you guys get that? If I need to come up with another one, we can. So we got a yes, a yes, a yes, and Morgan, are you with us? Morgan, there you go. Okay, good. Excellent. So that's basically section 6 in a nutshell. It's really just taking what we did in sections 4 and 5 and changing the story problems is basically what that section is. So, you know, it's kind of different. I like it. There is, I believe it's page 46. It's the second half of the video of the CPI. It starts around 9 minutes. But there's a page, and that last page is kind of, I don't want to say it's important, but there's a way using CPI to tell whether something has grown faster or slower than inflation. And that's kind of, how do I say this? Okay, if we talk about this problem that we just did, so we found out that the comparable price would have been 155, 824, 51, right? This is what it should be with inflation. Okay, well, let's pretend that the actual price of the house in 2007 was 140,000. So you can play kind of the what if game with this. So it should be 155, but it's only 140. That means this did not increase with inflation. Or it did not keep up, you might say. It did not keep up with inflation because it should be higher than that. And this is something that it's kind of a conceptual thing that you're going to have to wrestle with. If the actual is less than the should be, and the should be comes from our proportion, then it did not keep up with inflation. If the actual is greater than what it was, then it grew slower than inflation. Yeah. So you might have to go through and kind of think back and forth. And there is a good example of that. I think I'll post that video as well with the directions of where to catch up on that, because I talk through it with with an example of minimum wage. And it's good to kind of see how that works and with that problem. So I'll post that video too. The 9-minute mark. I think the video ends up being like 4 minutes long if you fast forward to where I asked you to start. But it's really just a good spot where it talks about that, because I'm pretty sure that in the past that kind of a question has been on the exam. That doesn't mean it'll be this time because it changes every semester, but it's a good concept anyway. And that's also on the practice page for this section is also, there's an example of that. So I'll post both of those videos and we can kind of go from there. So, all right, any other questions in section 6? No? Section 6, okay. All right, so section 7 is working with percentages, and we have 2 different ways to do this. One, you can set up a proportion and solve the proportion, or the other way is doing an equation. And frankly, I don't care how you do it. Some problems I find easier with an equation, some problems I find easier with a proportion. So for the first couple problems, we're going to do it both ways. With proportions and with an equation, because I want you to see how it works both ways, and then you can really kind of choose from there how you want to do it. Some people really love proportions, some people really love equations, and frankly, I don't care how you do it because mathematically they're equivalent. So it's really about whatever makes most sense to you, and whatever you like to do, that's what you need to do. So here's the deal. We're going to kind of go over an overarching thing here first. So basically with proportions, the nice thing about proportions is that you start with your percent. And percent is always out of how much? When I say percent, you should automatically think of 100. Exactly. So your percent is always going to go over 100. Always. And that means that you always have half of your proportion written without even thinking about what you're doing. So we have the percent over 100. And then on this side, we have is over of. And if you're thinking, what is that? Just hold your pants on. I'm going to explain. The is represents the part of the problem, whereas of represents the whole. So we're dealing with part to whole on the right side. With a story problem, you really want to think part to whole. Some of the other worded problems, you will see is and of as part of the problem, and then it makes a little bit more sense. Okay, so we have, that's kind of the basis of proportions. With equations, you have to remember that of means to multiply. Is means equals. And you have to change the percent to a decimal. That's kind of the bad part about equations, is that you have to do a little bit of extra work with the percents, whereas in the proportions, you just shove it over 100 and call it a day. All right. Any questions over the basics? give you a second in case you're taking notes, and then we will do some problems. All right, I'm going to go ahead and erase this drawing so that we can move on. Okay, so we're going to do this both ways. 16% of what number is 40? Now, if we're doing this as a proportion, we always start with our percent. So proportion means I'm going to put 16 over 100. Now, this is what I call this one an easy problem because of the wording. So remember, in our proportion, we have is over of. Well, is 40, so 40 goes on top of what number? Well, if we don't know, that's our unknown value of x. And we can solve our proportion, right? 16x equals 4,000. Divide both sides by 16. And I have 250. Boom. That's how the proportion is done. Stop me if I don't make sense, because that happens. Now, when you're dealing with an equation, the equation is a mathematical sentence. So basically, you read left to right. So I start with 16%. But remember, I have to change that to a decimal. So I'm going to take 0.16. Then I see the word of. Of means to multiply. What number is x? Is means equals, and then I see 40. So I have 0.16x equals 40. Well, mathematically, I divide both sides by the number in front of x, and I end up with 250. Okay. Now, depending on the problem, right, as I said, some of them, the equation is definitely easier. If you struggle changing back and forth between decimals and percents, equations are not the way for you to go, because you're going to have to change between decimals and percents a lot. And story problems, depending on the story problem, some can be difficult. All right, I want you guys to try one, and I would like you to set it up both ways. Just humor me on one, okay? So I would like you to try to set this one up both ways, and then we're going to talk about it. All right, so Brittany's ready. First, let's talk proportion. So since it says what percent, you should have x over 100 is over of. And there's the setup with the proportion. With the equation, what percent of 600 is 240? Now you would divide both sides by 600. You do have to make sure you move the decimal, and the answer is 40%. When you're doing the equation and you divide, your work will end up giving you 0.4. And that's where you have to go back and say, okay, the question says what percent. So changing the decimal to a percent, I got to move it 2 places, and that's how I get 40% here. Which on this side, you cross multiply, you divide, you just end up with 40. All you have to do is shove the percent sign on the end. Who has questions on this one? Going once, going twice. Okay. Do this one. I don't care how you do it. I'd like you to set it up both ways, but it doesn't really matter. At least one of the ways. All right, so we got a couple people saying 24. Do you all agree that it's 24? Does anybody not agree that it's not 24, I should say? Maybe we should start there. Everybody good? Do you need to see it? Are you good? You guys said you were good, so okay, we're going to be good. In that case, let's do story problems, right? These, as I mentioned, I think these are the easy problems. They're very straightforward. There's no trickery. Let's go to this one. Sarah's paycheck was $1,750 and she pays $800 in rent. What percent of her paycheck goes to rent? Go ahead and try to solve this one. And we will set this one up together, and I will use a proportion because that is my preferred method for story problems. Ashley, you're missing a key ingredient to your answer. You're very close, but mathematically it would be wrong. There you go. That little piece makes a huge difference. It's good. It's a good learning moment. Okay, since we've got an answer in the box, let's look at this. So when I'm doing this type of a problem, right, I always start with the percent. And here it says what percent. So I know that that's x over 100. I like using proportions because I can say I'm halfway done with my setup and I haven't even done anything yet. And that just makes me feel very efficient. So then we're doing a story problem. So we want to think part to whole, right? That's our thought process. Well, her paycheck is $1,750. That's her whole paycheck. So the whole paycheck is $1,750. The rent is only part of it, right? Thankfully, only part of her paycheck goes to rent. And there is our setup. Now, when you go to solve this, right, same thing as normal. We cross multiply. And the beauty, it pumps out 45.71. But remember, the question was what percent? So if you're using a proportion, you just chuck the percent sign at the end, and there you go. So in this particular paycheck, Sarah is spending roughly 45.71% of her paycheck on rent. Questions? Now, if you are a big fan of equations and you want to think through that, well, if you look at this, it says what percent, that's X, of her paycheck. So we're going to multiply that by the paycheck goes to rent. So we would have X times 1750 equals 800. Sometimes the wording is nice enough that it would make sense to use an equation. I don't want to think that hard. I want to do things the most efficient, the quickest way possible. You can call me lazy if you want. I call it efficiency, right? So you want to just make sure that you get to the point as quickly as possible. I feel like I can get there with proportions that way. If you like equations, right, ride the wave. It's your world. Any other questions here on this particular number 8? Nope. Everybody good? Okay. Let's do one more. Go ahead and try this one. Ooh, we got 2 different answers. Never mind, I'm wrong. That's funny. All right. So we're starting with, again, percent. Percent always goes over 100. Now, 48 students think math is the best. Is that all the students or part of the students? Well, part, exactly. So the part goes on top. The whole, in the question, how many total students, that's kind of a dead giveaway. How many total students, that goes in the bottom. So when you cross multiply and you divide, as I think Lil put, you get 133.33. Yeah. Now, with story problems, you kind of have to think logically about what this is saying. Can you have 0.33 of a person? This partial. No, exactly. So we would we'd probably round down. And so we would say there are 133 total students, because you can't have a part of a student. All right. What do you guys think of section 7? Do you want to do more problems? That's all I have prepped for section 7, but I can come up with more right now if you want. It's a very straightforward section once you understand how the pieces fit together. But you guys, you say you are getting it, it makes sense to you. Any questions about that? Does anybody want additional examples? I guess if you do, you can always stay on and we can chat after. I mean, we got 19 minutes left. We got a ton of time. I should have added more examples, but I don't want to bore you to death. If you know how to do it, there's no reason to beat a dead horse, right? So, okay, if you guys all feel good, let's kind of talk about next steps. So, I talked about what's due this week, right? You have 2 web work assignments. You got the Excel assignment, which I will post the Excel help video. I will post 2 videos that I recommend you watch from the packet. I don't know how much you guys are watching of the videos from the packet, but I'm going to post 2 also that I recommend. If you don't do it, you don't do it. I'm never going to know, right? And then you have a quiz and you've got a discussion board. So get that discussion board done now. Now that you've been to the session, you can knock that out, get that, again, easy points. You want to make sure you get those. Okay, next week in the live session, we're finishing Unit 1. So sections 8 and 9, that'll be done. The first project is assigned next week. In this live session, I will be bringing up the project. I will be talking through it. I will be answering any questions you might have as we go through it. I do have a project help video also. I will post that next week with the live session. So anytime we introduce an Excel assignment or a project, I have help videos for most of those, and I will post those along with the live recording. That will kind of be a weekly thing from now on. So even if you are in the live session as you 6 are, you still may want to go back into that announcement because there may be videos there that'll be beneficial for you. So just keeping that in mind. And then 2 weeks is the exam. So next week, we will also talk through all of the exam information. I will kind of walk you through how you schedule your exam. If you don't know how to do that, that might be very, very helpful. And we'll talk through any questions you have about that. So 2 weeks from today is exam week, and you can take the exam anytime during the week as you want. The session that week is simply a question answer session. I will have nothing planned. I will have a blank screen, but I will be here as long as I need to be from 1 to 3, whatever. And it's just for you guys to ask questions. If you've already taken your exam, well, then you would definitely not show up because you probably don't have any questions, unless you have project questions, because those work too. So the week of the exam, it's simply question answer, or if you say, can we do a couple more examples on CPI or on this or that, anything that you might be struggling with, we'll do that too. So next week is kind of a lot of information. We'll spend 45 minutes or so finishing Unit 1. Then we'll talk about the project. We'll talk about the exam. So big, big information coming next week. If you can be here live, that'd be great, because then if you have questions, you can get them answered right away. If you have to watch it later, then you got to kind of wait on emails and things. One thing that I want to let you guys know, I teach late on Tuesdays and Thursday nights. I go to class at 5:30. I don't get done till 9, which means I don't get home till 10. I don't answer emails. After about 4 o'clock on Tuesdays and Thursdays, I don't answer emails because I'm getting prepped for class. I'm doing things for that. And then when I get home, I don't work. After 10 o'clock, on Tuesday, Thursdays, I just don't work. So if you email me anytime, probably about after 4 on those days, do not expect a response until the following day. I just want to let you guys know that's why. I'm not ignoring you on purpose those days. I just have other obligations. So that's kind of where we are there. Okay, that was a lot of rambling. Do any of you have any questions about anything that we're doing right now? Oh, Ashley says yes. Okay. And I know, Ashley, you emailed me yesterday, and I did respond to those this morning after I got out of class. But yeah. So if you don't have any questions, you're free to go. If you do have questions, stick around. We'll get those answered. And I'll see you guys next week. Email me if you have any questions, and then look for the Excel video under the announcement later today. Okay. Yes, in WebWork you get credit for the ones you did get right. So on every individual question, so in section 2 there were 19 questions, and every time you hit submit, it keeps track of whether or not you got something right. So there were 77 total points in section 2, and I would say about half people got 77. Some people got 70, 72. You get points for what you do. Yes, yes. And that's where it's definitely beneficial to start the homework early. That way, if you have questions, we have more time to go back and forth, because sometimes it takes a couple back and forth emails to get it all ironed out. And the earlier that happens, the better. But yes, as long as you hit submit, you get credit. And yeah, better to learn now than the last week of the semester, right? That's good. That's good. So you should see in WebWork, you should be able to see how many points you got for a section if you go under maybe progress or grades. And then that score should have been transferred over to ID Learn. I did that this morning, or this afternoon, I guess. Anybody else have any questions? You're all still sticking around, so that's good. Yep, I try to do them whenever they're due. I try to get them up the very next day. Because if you did it, I want to make sure that we constantly have an idea of what's happening. Yeah. Yep. Okay. Anything else? Oh, that was weird. I should have left. Oh, okay.